Good day, everyone. Thank you for attending this session for Intro to Open Cluster Management. My name is Mike Yang. I'm a developer for the Red Hat Advanced Cluster Management for Kubernetes team. I'm joined today by my other Red Hat colleagues as well. This is a pre-recorded video. We do encourage you to ask questions, but after the presentation is done. So what is Open Cluster Management? It's a new open source Kubernetes multi-cluster centric project that has been launched by Red Hat and Angu. We created this project as a way to engage the open community in an effort to simplify the problem of managing many Kubernetes clusters. This project is not trying to reinvent the wheels and solve problems that are already well addressed in the community. For example, for provisioning and upgrade and deprovisioning of clusters across many different cloud providers, there are already projects like KubeSig, Cluster API, and the OpenShift Hive projects. For health metric of many clusters, there's projects like Thanos. For compliant aspect of those clusters, there's projects like Open Policy Agent. So what we're focusing on how Open Cluster Management as a community project build additional capabilities that help bring all these separate tools together so that you have a central location with a unified view of inventory of clusters and have a unified way of delivering managing agents. The managing agents can help to configure projects like Thanos that need certain configuration across many clusters to collect health metric data. We also have a native way of delivering application across multi-clusters that can with other community projects like Argo and Kubeflow. We also have a native governance policy framework that can be integrated with other compliance projects like Falco and Open Policy Agent. So Open Cluster Management is really about bringing all these many different parts of a community and deliver a whole solution to simplify fleet management across the open hybrid cloud at scale. So for any community project that wants to become multi-cluster aware, what aspects do they need to address? So let's talk about some of the requirements. There are projects like Open Policy Agents or Falco that doesn't have multi-cluster concepts built in. So they need to become multi-cluster aware so they can understand which clusters to enforce compliance on. There are also other projects that understand the concept of multi-clusters like Argo and Thanos, but it's not a unified experience. Different projects have different concepts of what it means to be multi-cluster. So let's consider all the requirements that a service within the Kubernetes ecosystem will need to become multi-cluster aware. So first of all, the service must have an API to determine the inventory of the available clusters. So for awareness of cluster inventory, Open Cluster Management provides a Managed Cluster API represent the cluster under management. Another requirement is the service must have a way to determine where to schedule and assign Kubernetes API manifests to a selected set of clusters. For this service, we provide an API called Placement, which for awareness of workload and configuration schedule to provide the ability to describe the expected characteristics of ideal set of clusters, and the placement controller will examine the available clusters and dynamically match a list of clusters that's captured by the placement. Another multi-cluster aware service requirement is it must be able to deliver Kubernetes API manifests to a selected set of clusters. For delivery of configuration, Open Cluster Management have a manifest work API which provides a simple way to specify one or more Kubernetes manifests that should be delivered and reconcile against the managed clusters. Lastly, the service must have a way to govern how users access available clusters or groups of clusters in a fleet. So for this security requirement, Open Cluster Management to define a consistent access control boundary, users or groups may be assigned to a specific managed clusters or collection to a managed cluster known as Managed Cluster Sets API. For example, we might have 3 teams that each have access to only clusters that are related to their day-to-day activity. If a particular team wants to perform an application or configuration or policy change, we only want them to change their subset of the fleet and not impact the other team's clusters. Another core concept that might be optional is a service that might need to extend the management agent with additional built-in controllers that should be run on managed clusters. If the server has a need for that, then to install built-in controller or operator on the managed clusters, we provide the Managed Cluster Add-on API, which allows additional behavior to be injected remotely into the management agent to support abstraction built around the manifest work and the other core primitives. So at the bottom here, we see there are lists of projects that are possible consumers of these multi-cluster core APIs. For example, we have created a Submariner add-on operator that helps you simplify provisioning Submariner across a set of clusters so they can interact with their network layer easier. We can also help create a multi-cluster operator that deploy at Fanos data store on a central control hub and then link back to the clusters that are in the fleet so their in-cluster Prometheus can share the correct data. We also built examples that syndicate desired policy for Falco or Open Policy Agent so that it's managed at a fleet-wide level as opposed to a cluster-by-cluster basis. And with Argo, not only we orchestrated the distribution of Argo into your fleet, we have also been working with the Argo community to help adapt concepts like the placement API in a generic way. So the Argo project and the community can leverage concepts like the cluster inventory, role-based access control, placement APIs, etc. So once again, these are the core principles that make up the open cluster management. So we've been describing the problem with multi-cluster management and some of the requirements, and we talk about the concepts and the APIs that help simplify the fleet management. But what is the actual architecture underneath open cluster management? As you can see from the diagram, open cluster management uses a hub-to-agent framework. The hub cluster acts sort of like a multi-cluster control plane. It hosts the cluster manager operator, which contains the registration controller, and it communicates with the registration agent on the remote clusters for registration and lifecycle of managed cluster and cluster add-on. The placement controller on the hub cluster is responsible for workload scheduling across multiple managed clusters. On the managed cluster side, there's a cluster-led operator which contains the work agent on the managed cluster, which pulls the placement decision from the hub cluster and launch workload to the related managed cluster. It's also periodically push the status of the managed cluster to the help cluster. So with this architecture, we avoid vendor logins because the APIs are not tied to any cloud providers or proprietary platform. You can have your hub cluster initialized on any Kubernetes provider or platform you like, and you can have many different clusters from different providers that join that hub cluster with no functional limitation. So open cluster management overall is like a microkernel operating system. It has foundational parts to provide the core function that we described, but also has various add-ons to extend different capability. Some of the built-in add-ons are the policy add-ons that we described earlier, as well as the application delivery add-on. They are also highly modular and can be deployed separately. This makes it easier for projects to adapt the open cluster management API so they can become multi-cluster aware. Let's do a demo and showcase the foundation layer of open cluster management. Firstly, we're going to show you how to bootstrap a multi-cluster control plane that we call the hub cluster. Then we're going to register another cluster to the hub cluster so that it can be managed by the hub cluster. There are many ways that we can bootstrap this process. We can use the available operators from the operator hub, or what I'm about to show you, which is using our in-house cluster admin binary. It is a tool that we created inspired by the Kubernetes kubeadmin tool. So if you're already familiar with the kubeadmin tool, then the workflow we're about to show you should be quite similar. So on my screen right now, I have two terminals. On the left side, I have a newly created kind cluster that I'm planning to use as the multi-cluster control plane that we refer to as the hub cluster. On the right side here, I also have a newly created kind cluster that I'm planning to use to perform the action of joining the cluster to the hub cluster. So to start off, we run the cluster admin init command on the left side of the hub, which will represent the hub cluster. This will deploy the cluster manager operator, which contains the controllers such as registration and placement. It will then print out the command with a temporary token that another cluster can use to join the hub cluster. So let me copy and paste this command. So using my command on the right side, which is the to be managed cluster, I will initiate the join process. So while this process takes place, let's go back to the slide and talk about what's actually happening underneath after running the join command. In Open Cluster Management, the cluster registration follows a double opt-in mechanism, which is the agent opts in to register a cluster with the hub by creating a managed cluster resource on the hub. It also creates a certificate signing request, which means the agent will need a kubeconfig with appropriate permissions to initiate the registration request. And that temporary token that we just copy and paste from forms the Bootstrap hub kubeconfig. Then the agent on the managed cluster side will generate the kubeconfig-secret. When the hub receives the registration request, the admin user on the hub will need to approve the certificate signing request initiated by the managed cluster, so then the managed cluster agent is authenticated to the hub. The admin user on the hub cluster also needs to set the value in the managed cluster custom resource field to hub accept client to true, so the agent is authorized to call the hub. With this authentication and authorization approval, this is what we call the double opt-in. So some time has passed. Let's look on the hub clusters. We see the managed cluster resource has been created, but as we talked about earlier, the hub accepted is currently false. It's waiting for the admin approval. There's also a certificate signing request. As we mentioned earlier, the condition is currently pending because the admin hasn't approved yet. So to continue this workflow, we go on the hub cluster and accept the managed cluster join request. So if we check the managed clusters again, we can see that the hub is now accepting the managed clusters request. It's authorized to accept the managed cluster request. It's also authenticated to accept the request because the certificate signing request has now been approved. So after the approval of the registration on the hub, a namespace with the same name of the cluster will be created. And just as I mentioned before, when I joined the cluster the first time, I gave it the cluster 1 name. So I should be expecting a namespace here with the cluster 1. So this namespace can be regarded as a container of the resources that agents in a managed cluster can access. By default, the agent on a cluster is only authorized to access certain resource kinds in this namespace on the hub to ensure security isolation. So with these few commands, we were able to bootstrap a hub cluster and then have another cluster join that hub clusters. So after the registration process is done, we can now leverage the APIs that are available provided by the Open Cluster Management. So these are some of the APIs that I mentioned earlier. We have the placement, the manifest works, the placement that finds the managed clusters. We have the managed cluster sets for role-based control. We have the placement to find those managed cluster sets. And then we have the manifest works that can deliver workload from the hub cluster to the managed cluster. So with these APIs, we'll allow projects to develop new solutions with multi-cluster capabilities or enhance any existing project using these APIs to become multi-cluster aware. So that wraps up the demo, as well as the quick introduction to Open Cluster Management. For more information, please visit our website at open-cluster-management.io. We're currently in the process of joining CNCF. We have a bi-weekly community meeting that we really encourage you to attend. It's open every bi-weekly Thursday, 10:30 Eastern Time. Anyone can join. You can find the details on the website. You can also find us on the Kubernetes Slack channel. The link is on the website as well. Please feel free to download and play with the cluster admin tool that we demoed. Or if you're only interested in a certain API, please feel free to check out any projects that are under the GitHub open-cluster-management-io. Thank you again for attending this session.